a big fish in the pond, the most established equation of motion. So the objective of my bookwork here is to derive the displacement equation. One is a rectangle OACD. Hope all of you analyze this. Area of the triangle, half base into height. Half base of the triangle is AC, height is BC. Hello students, continuing further with our discussion on straight line motion. What did we call straight line motion as? Yes, motion in one dimension. Why did we do so? Because here we require only one axis to describe motion. Therefore, in simple terms, we call it as one-dimensional motion or straight line motion. What was that we were accessing hither to this class? Sir, using VT graph, we were discussing equations of motion. What was a VT graph? Velocity time graph. I understand the nature of one-dimensional motion by plotting a VT graph. We considered several situations: body starting from rest, body already having some initial velocity, body moving with uniform positive acceleration, negative acceleration. And all in these cases, we plotted VT graph. And therefore, what was the significance of VT graph? Sir, the slope of the VT graph gives us, yes, the acceleration of a moving body. And the slope of XT graph, position time graph, gives us, yes, the velocity of the moving body. Now, continuing further, in my today's session, using the VT graph, the so-called velocity time graph, I will be deriving the second equation of motion, which is S equals ut plus half a t square. This equation is also called as the displacement equation. So the objective of my bookwork here is to derive the displacement equation. Dear students, which equation is called the displacement equation? Yes, equals ut plus half at square. So which fish in the pond I am targeting today? The displacement equation. And what is the aid I am referring to arrive at this expression? It is again our VT graph. Now, to begin with again, along the x-axis, I have plotted time, and along y-axis, I have plotted velocity. Our VT graph naturally, quantity along x-axis is time, and the quantity along y-axis is velocity. The same considerations that I referred to my previous derivation. Initially, the body is at rest. It is not moving. The body is at rest initially to begin with. So where is its position marked? Along the origin. So my initial position when the body is at rest is along the origin. Now, as there is progress of time, time increase ಆಗ್ತಿದ್ದಂಗೆ with a lapse of time, the body starts moving. It starts acquiring some velocity. What did I call that velocity? A very beautiful term, initial velocity. Therefore, now the body starts moving with some initial velocity u and reaches the point A. ಮೊದಲೇನಾಗಿತ್ತು? ರೆಸ್ಟ್ ಅಲ್ಲಿತ್ತು ಸರ್. So where was its position? At the origin. As time has progressed, the body has started moving. It moves along the y-axis. It has some velocity now. I call that to be initial velocity. And it has reached the point A. What is happening along the point A? At this point A, the body is displaced along a straight line. The moment it has reached the point A, at this point A, the body is getting displaced along the straight line AB. ನಾನು ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀನಿ straight line. Yes, uniform displacement, and hence the acceleration along AB is also uniform. Why? Very clear, sir. It is getting displaced along this straight line. AB is uniform displacement. Hence, along AB, it should have uniform acceleration. Now, I draw a perpendicular BD to the x-axis. Andre, from B, the body is coming back to rest. It is coming back to the x-axis. with a velocity v, where v is the final velocity of the body. So the perpendicular BD represents v, which is the final velocity of the body. Therefore, by description, OA represents u, which is the initial velocity of the body. BD represents v, which is the final velocity of the body. And BC, if you observe the diagram, I've constructed a triangle ABC. Yake? Yes, sir, you taught us uniform acceleration has to be calculated. Slope has to be calculated. Therefore, we require a right angle triangle. Coming next, from the diagram, this BC is nothing but BD minus CD, which is V minus U. So, BC is BD minus CD, V minus U, and AC equals OD equals T, which is the time. So these are the initial considerations made. These are the web I am spinning to pond my fish. Now, my whole aim here is to calculate S, which is the displacement along the line AB. Let us refer back to the diagram. I have to calculate S. Displacement equation ತಾನೆ ನಾವು derive ಮಾಡ್ತಿರೋದು. Yes. So S has to be calculated, which is the uniform displacement along AB. Now, how will I calculate this? Yes, my basic knowledge should say the area under the curve. Which is the curve? O, A, B, D. This area, the shaded part, should give me the displacement AB. So, my dear students, how will I calculate the displacement? Yes, it is area under the graph O, A, B, D. So this area is giving me the displacement. Now, if you observe, I can split the graph into two geometrical figures. The entire graph, the so-called graph, can be split into two geometrical figures. Which are they? One is a rectangle O, A, C, D. Hope all of you analyze this. The first one is a rectangle O, A, C, D. The next one is a good triangle A, B, C. So the area of this rectangle plus the area of this triangle will give me the area of that curve. Therefore, area of rectangle OACD plus area of the triangle ABC. So S equals area of the rectangle. Recall, area of a rectangle, length into breadth, OA into OD. So that is what I have written, OA into OD, which is area of the rectangle. Area of the triangle, half base into height. Half base of the triangle is AC, height is BC. Now substituting for these terms from my considerations, OA is nothing but U. OA is U. OD is T. I've already clearly explained that in my considerations. OA is U. OD is T. Half. Again AC time T. BC we have written as V minus U. I have clearly done that in my consideration. Or S equals U into T is UT, half T V minus U. But what is V minus U? If you recall my first equation, V minus U is equal to 80 because I have clearly written V equals U plus 80. So V minus U is equal to 80. So substituting for V minus U, S equals UT plus half. This T is retained as it is. V minus U is AT. Or simplifying, S equals UT plus half A. T into T is T square. So I have derived beautifully the displacement equation using a VT graph. Therefore, if you clearly observe, the distance traveled by a body, the displacement of a body in a given interval of time t depends upon the initial velocity and acceleration of the body, whereas it is independent of the final velocity. So S equals UT plus half AT square. Now, continuing further, now a big fish in the pond, the most established equation of motion, V square equals U square plus 2AS. The third equation of motion, V square equals U square plus 2AS. 1983 Prudential Cup significance. 1983 World Cup. So significant is this derivation. Now, as usual, time along x-axis, velocity along y-axis. Very good. See, now the parameters are at the tip of your tongues. U, initial velocity. Yes, uniform displacement. V, final velocity. BC, V minus U. All these things same as we have done from our previous derivations. The same considerations. OA is U, initial velocity. BD is V, final velocity. BC is BD minus CD. BD site iddange same agide, quarters gal kottbittidare. V minus U. AC equals OD equals T. The same steps, whatever I have followed for the displacement equation. Now, I will highlight here S equals UT plus half T V minus U. Displacement equation nige yen bardidini, the same I have continued. I have to eliminate 2 from the denominator. So, yen madbeku? Throughout this equation, multiply by 2. Whatever equation I have highlighted, multiply that equation by 2. So, you have 2s, 2s aito, 2ut, 2 and 2 gets cancelled. So 2s equals 2ut plus t v minus u, or 2s equals 2ut plus v into t vt minus u into t ut. A bracket na simplify ಮಾಡಿ open up ಮಾಡಿದೀನಿ. V into t is vt, u into t is ut, or 2s equals vt I have written as it is. This is 2ut minus 1ut, which is ut, or 2s equals t is common here, v plus u. Now we divide both sides by t. 2s by t is v plus u, equation 1. See what I have done? Both sides I have divided by t. So this is divided by t, this is divided by t. T and t gets cancelled. And again, from my first equation of motion, v minus u equals at. Multiplying these two, left hand side nodi multiply madana first. 2s by t into, here left hand side is at, equals v minus u into v plus u. T and t gets cancelled. 2as equals, this is of the form a plus b, a minus b, or b square minus u square. So finally, I have arrived at b square equals u square plus 2as. So very simple. ನೀವು observe ಮಾಡಿದ್ರೆ, if you are using VT graph, and if you are familiar with one derivation, the other two becomes very, very simple. So I have used VT graph to derive all the 3 equations of motion. Expected that all of you have thoroughly understood this. In my next session, I will have a shield off for motion in 1 dimension by learning a very beautiful phenomenon called free fall. Until then, take a sheet of paper, equation 1, 2, 3. Equation 1, 2, 3. Because nothing makes man perfect than practice. Practice. Until then, thank you.